I am your chemistry teacher Umesh Kumar Gupta. Today I will take problem number 1.4 of NCERT class 11th book, paper first. The problem is calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burned in air. If carbon is burned in air, so oxygen present in air combine with carbon to form CO2. So 1 mole of carbon is burned in air. 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide, 1 mole of CO2. So according to this equation, we can say that 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. So as in problem, 1 mole of carbon is burned in air. So if you will burn 1 mole of carbon, you will get 1 mole of carbon dioxide. And 1 mole of carbon dioxide is equal to 44 gram of CO2. As we know, what is mole? So mole is mass of 6.023 into 10 to the power 23 particles of any substance in gram. So this is the molar mass of carbon dioxide, and this is the mass of this number of particles in gram. So if you will burn 1 mole of carbon, so you will get 1 mole of carbon dioxide if oxygen is present in excess. So another problem is 1 mole of carbon is burned in 16 gram of dioxygen. 1 mole of carbon is burned in 16 gram of oxygen. 1 mole and mass of oxygen is given in gram, 16 gram. So how much CO2 will produce? So as we know, 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. So how is mole calculated? So number of moles can be calculated by mass by molar mass. So mass is given 16 gram and molar mass of carbon dioxide O2 is 32. So number of moles will be 0.5. So 16 gram of oxygen means 0.5 mole of CO2. No, 0.5 mole of oxygen. So 1 mole of carbon is burned in 0.5 mole. This is mole, so this is also must be in mole. So 1 mole of carbon is burned with 0.5 mole of oxygen. How many moles of carbon will produce? Since 1 mole of carbon reacts with 1 mole of oxygen, but in this problem 1 mole of oxygen is present, but no 1 mole of oxygen is present. Oxygen is only 0.5 mole. So 0.5 mole of oxygen will react with 0.5 mole of carbon to produce 0.5 mole of carbon dioxide. This is present in less quantity and this is in excess. So when 0.5 mole of oxygen will combine with this, so this will remain 1 minus 0.5 mole. So 0.5 mole of carbon will remain, but 0.5 mole of oxygen, 0.5 mole react, both result now O2, all the O2 present in this reaction will convert to carbon dioxide. So the reagent which is completely used in the reaction is called limiting reagent. So in this reaction, in this case, O2 is limiting reagent which decide how much CO2 will produce. This carbon is present in excess. So this carbon is present is 1 mole and oxygen only 0.5 mole. So if you burn 1 mole of carbon, you need 1 mole of oxygen. But in this problem, only 0.5 mole of oxygen is present. So 0.5 mole of oxygen will react with 0.5 mole of carbon to produce 0.5 mole of carbon dioxide. So this oxygen will completely consumed and 0.5 mole of carbon will remain. So this is excess reagent and this is limiting reagent. So 0.5 mole of carbon CO2 will produce. And you can convert this in mass. So how is mass calculated? Moles into molar mass. So mole is 0.5 and molar mass of carbon dioxide is 44, so it will be a 22 gram. So 22 gram of CO2 will produce, or 0.5 mole of carbon dioxide will produce in this reaction. Now next, carbon, oxygen, CO2. In this reaction, 2 mole of carbon reacts with 0.16 gram of oxygen. 16 gram of oxygen means 16 by 32, 0.5 mole of oxygen. So 2 mole of oxygen reacts with 0.5 mole of carbon dioxide. So according to equation, we can say that 1 mole of carbon react with 1 mole of oxygen to give 1 mole of carbon dioxide. But in this reaction, only 0.5 mole of O2 is present. So 0.5 mole of oxygen will react with 0.5 mole of carbon to give 0.5 mole of CO2. So this reaction completely consumed, and this will remain 2 minus 0.5. 1.5 mole of carbon will remain. So it is excess reagent, and this will completely consume. 0. This will not remain. So this is limiting reagent, LR. And in this reaction, you will find 0.5 mole of carbon dioxide. And this mole can be converted into gram. We have to use this formula, W. Mass of any compound is gram is equal to number of moles into molar mass. Number of mole 0.5, and molar mass of CO2 is 44. So you will get 22 gram of carbon dioxide. 0.5 mole of CO2 or 22 gram of carbon dioxide.